So that is 1 minus probability of this. So all are coming from here. You know what I mean? Okay? So that is again, there are 10 people in the class, so 10 choose 3. That is a number of all possible samples that you can make. Well, only non-debating, so that is and A choose 3. Okay? So we see this one more time. That is 1 minus 56 over 120. So that is 64 over 120. That is again 0.533. Okay. Again, it sounds very different. The balls in the urn or those toys in a box, and here what students in a classroom. Okay, so sounds very different, but what you want to notice over here is again there are 2 types of students: the debate team or not. Okay, and those number compositions are just the same, so that's why you see the same answer again and again. Okay. Well, example 4 is very, very relevant, unfortunately, and we are very sensitive about this issue right now. Yeah. Medical screening. Oh, well, this is suppose that a cruise ship returns to the United States from the Far East, unknown to anyone. 4 of its 600 passengers have contracted a rare disease. So at the port, yes, Public Health Service screens 20 passengers selected at random to see whether the disease is present aboard the ship. Okay, what is the probability that the presence of the disease will escape the detection? Let's summarize over here. That is example 4. I'm going to write down this. Medical screening. Okay? Medical screening. So that is, there are 600 passengers in a cruise ship, and unknown to anybody, probably the person themselves, okay, 4 of them contracted a very rare disease. So I'm going to say just sick. So the rest, which is 596 people are healthy. Upon their arrival at the port, the Public Health Service Department sends a crew to screen these people. So what do? What they do is select 20 passengers at random and screen them. Okay. At random, of course. So, and in this process, what is the probability that this disease escapes detection? Escapes from detection. So in other words, nobody would know. Okay? They will not be aware of this kind of rare disease. So it's going to spread, right? Okay. So over here, why does it happen? The health service officials select only 20 over here, so escapes from detections. Why? Because only healthy people were selected. That's why. You know what I mean? Okay, so let's make it here. Healthy people over here, all 20 are from this group. Okay, so can you set up this probability? This probability is going to be regardless of their health condition, there are 600 people, so 600 choose, okay, combination, 600 choose 20. And that is the denominator. And the numerator is the event that you are observing over here. All 20, only 20, the healthy ones are selected in the sample. So that is 596. Choose 20. Okay. So what is the probability? So let's look at that. Okay. That is 596 over this. So P of 596, 20 divided by 20 factorial. Isn't it? And over here is permutation 600 choose 20 over 20 factorial. So 20 factorial just cancels out. Okay? So let's compute what that is. Okay. So 596 math, go to probability. I'm going to go to just a combination because that will be a less number. So go to number 3 option and 20. So that is 9.52 times 10 to the 36 power. Okay, I'm going to just go to this much. 9.252 times this. And here, okay, and here, so that is 600. Oops. 600 and this 320. That is 1.09 to the 10 to the 37th power. So, how do you calculate this? That is, this is 10 to this, they cancel, so just 1 and this 10, that's what's left. So that is 9.52 over 10 times 10.9. That's what that is. Okay? So 9.52 divided by 10.9. That is 0.87. Okay? So I'm going to erase all of this. And that as a result, what you have over here is 0.87. In other words, 87% of the time, the disease will escape from this action. Isn't it remarkable over here? Okay, 87% of time, even just only 4 people out of 600 got sick. Okay. So, if you were health department official, well, would you be satisfied? Maybe not. It's very, very alarming over here. Okay? So how can you improve the process? Well, you want to just screen more people. Instead of 20, you would screen 50 people or even 100 people. Well, if the case, then the probability will go down because the denominator is going to be getting a lot larger. Okay? So that means it's going to take more time and yes, it's going to be a lot more time. Time is money again. Okay? Yes. So, but sometimes they have to do it, right? Yes. So, this is one case that, you have to go around. If you just use a calculator directly, you are going to get the answer like this. So you should be able to reduce this one to just look at the power, 10 to the 36 power, 10 to the 37 power. also reduce, that is just 1, and this is 10, and this is how we compute, that gives you 87%. Okay? Next. All right, I'm not going to do example 5. No, that's fine. Go to example 6. Again, balls in an urn. An urn contains 6 green balls, and 7 red balls. So altogether there are 13 of them. Okay? A sample of 4 balls. Selected at random from the urn. Find the probability that A is the 4 balls have the same color. In the sample. It doesn't matter whether that is green or red, just the same color. So when does it happen? It could be what? It could be just all green, or what? Would be all red. Agree? Okay? So there are 2 possibilities over here. So the first case is all green, like this, or 6 and 7, 6 green, 7 red, and all 4 coming from here. Make sense? Okay? So, here we go. All 4 of them are green. So probability that only green are in the sample, so that gives you 6 choose 4. Over what? What is the denominator? The denominator is always just all possible samples. Well, regardless of color composition, well, there are 13 balls, and we make a selection of 4 for a sample, right? So that is 13 choose 4. Okay. This case or this case, they are mutually exclusive, aren't they? They are all green or all red. They are mutually exclusive, so just you are safe to just add them up. Okay? Add, there's nothing to subtract. So here we go. This time, 7 choose 4 over same thing. 13 choose 4. So you have this and add them up. Okay. So that is, let's use a common denominator. 13 choose 4. So 6 choose 4. I always change this one to 6 choose 2, because then, you remember, it is like you pick up, let's say, 4 sweaters out of 6 you have. If you pick up 4 sweaters, that means what? 2 sweaters are not picked, right? So, same thing. Just you count those not picked ones or those the picked ones. The same thing. And over here is a 7 choose 3. Well, how can I do it in my head? This is 6 times 5 divided by 2 factorial. If you do not think about it, just don't be stressed out. Use your calculator and then you can do it. So this is 15. And 7 choose 3, that is 7, 6, 5 divided by 3 factorial. So this is cancelled, so 35. Yes, that's what I do most times. So this gives you 50 over, what is that? 13 choose 4. So 13 choose 4. That is 715. So 50 divided by 715, that is roughly 0.069 0.99. So could you say that this is just 0.07? Okay, 0.07, so that is 7%. So 7% of the time, yes, you are going to see just the same color in the sample. The next one, yeah, part B. All right, so. Again, the same process, you are going to make a sample of 4. The sample contains more green balls than red balls. More green than red balls. So, look at all these compositions, okay? When you have a sample, all possibilities like a green and red. It could be 0 and 4, or 1 and 3, 2 and 2, 3 and 1, 4 and 0. There are the only possibilities, right? Okay, because we select 4 for the sample. So, more green than red. This is not it, this is not it, or it's more, they are equal, this is not it. But what about this? Yes, this is it, and this is it. So these two cases. So that means 3 green and 1 red, okay? Or what? 4 green. Okay, so let's set up. And both are what? Mutually exclusive case, okay? Mutually exclusive case, so just we set up probability and add them up. So 3 green, so that is 6 choose 3. And 1 red, so that is 7 choose 1. Okay, we are going to this one and this one make one sample, so you have to multiply. Okay, divide by, yes, that is 13 choose 4. Or, this case, all green. Yeah, all green, so this time 6 choose 4, divide by this, 13 choose 4. Make sense? So, just don't be overwhelmed, just look at this, write down all the possibilities, and these two cases are indicated over here. So what this is, over here you multiply these two, gives you 140. What was 13 choose 5 earlier, I remember, so 700 something. 13 choose 5, I'm sorry, 4, 715. Plus, here 6 choose 4 is the same as 6 choose 2, so that is 15. 6, 5, yes, 15 and 715. So that is 155 over 715. So let's divide. 155 divided by 715. That is 0.2168. So that is 21.7%. Okay. In my math lab, they are going to ask you just round your answer to each decimal places, and then you just follow the instruction. Yeah, I'm looking at the clock because I try not to go over 75 minutes, okay? All right. Committee selection, example 7. Okay, this is an interesting question. The U.S. Senate consists of 2 senators from each of the 50 states. Everybody learned that. 5 senators are to be selected at random to form a committee. Okay. What is the probability that no two members of the committee are from the same state? So there are 50 states and there are 100 senators. We are going to select 5 senators to form a committee. And we do not want to have just 2 senators coming from the same state. Okay, so we need more representation from other, those people. So not from the same state. So what is the probability that those none from the same state? Okay, from the same state. So what do we think over here? So when you set the probability, always you are going to have just all possible outcomes over here. So number of all possible outcomes. In this case, just different. Okay, so none from the same state. The number of outcomes like that. Okay, so that is, let's calculate all outcomes. There are 100 senators. So 100 senators, we choose 5 of them. And just 5 senators to form a committee. So this is a combination case. Okay, combination. This is an interesting case. None from the same state. How can you prevent that? How can you prevent that just 2 from the same state? So for example, 2 senators from Florida. Well, we don't want that because we want to have more representation, okay? So what is that? So that is, let's put it this way. Let's pick, rather than focusing on those senators, let's pick just 5 different states, okay? So choose 50 states. Choose 5 states. So 50, choose 5. But once you choose 5 states, each state has 2 senators. Isn't that right? Okay? So let's say state 1, state 2, state 3, state 4, state 5. So state number 1, state number 2, state number 3, state number 4, and state number 5. And each one there is a senator number 1 and a senator number 2. Correct? So 2 possibilities, just you choose one of those 2. So each one will bring 2 possibilities, 2 different possibilities, 2, 2, 2. Make sense? By doing this way, we chose 5 different states. Therefore, no one from the same state.